Hey everyone, this is Alex Velosky and you are watching my Teach 1 for this week's assignment, Causal Networks. Let's get started. So for this question, we're going to be using the network drawn below to write equations that would allow us to estimate what would happen if the intervention was not given. So basically there are two parts to this question. In the first part, we're going to be writing equations for each of the nodes in this network. And in the second part, we're going to set the intervention treatment node to 0, and we're going to see how that affects the equations we write out. So before we move on, just want to give everyone a little recap on linear regression. At the top here, I've added an example of a linear regression equation, and I've broken down each component we see in that equation below. So starting with y, that is the value of our response variable, alpha, which is, in other equations can be labeled beta sub 0, is our overall constant coefficient, and it's also the y-intercept. When you see beta, that is just a regression coefficient of an explanatory variable. It's also the slope of that variable. X is the explanatory variable, and E is our error term, which indicates the unexplained variance of our regression model. Okay, now that we're all refreshed on linear regression, we can move on to the first node in our network for this question, severity of illness, which I've labeled as beta sub 1. Because severity of illness does not have parents in this model, the equation is pretty simple. It's just its y-intercept, so severity of illness is just equal to alpha 1. And just a note, I've labeled it alpha 1 because I've labeled severity of illness beta 1, so if you see alpha 2, it will correspond to whatever beta 2 is, which we will see what beta 2 is in the next slide. Next we have provider's decision, another root node in our network. Similar to severity of illness, provider decision is equal to its alpha, or its y-intercept. In a larger network, both severity of illness and provider decision likely have parents, and we would add those parents to those equations. However, this is not the case since we are only focusing on the network we have in this question. The next node we are going to look at is do not treat preference, which I've labeled beta sub 3. If we look at our network here, we can see that do not treat preference has one parent, severity of illness, and we will add severity of illness to its equation above. So do not treat preference equals its intercept plus beta sub 1 severity of illness. Next we have intervention slash treatment, which I've labeled beta sub 4. If we look at our network again, we can see that intervention treatment has 3 parents in this network, which are severity of illness, do not treat preference, and provider's decision. These 3 parents will be incorporated into the regression equation for intervention treatment, which I've put that equation right at the top there, and it reads intervention treatment equals the intercept for intervention treatment plus beta sub 1 plus beta sub 2 plus beta sub 3. Here we have the final equation in our network. This equation was actually given as an example when we were reading off the question in an earlier slide, but I've included it again. So adverse outcomes equals alpha, or its intercept, plus beta sub 1 plus beta sub 4 plus E. Now in this network we see that random chance is a node in itself. However, random chance is just equivalent to the unexplained variance or the error term, so I've given it a label of E. Now that we've completed part 1, which was to write equations out for all the nodes given in our network, we can finally move on to the main question. Estimate what would happen when the intervention treatment was not given. Just a few things to note. All the variables or nodes in our network are binary, except for random chance and possibly severity of illness. Now I say severity of illness because severity could have multiple categories, like in the case of traumatic brain injury, where injury is categorized into not severe, mild, moderate, and severe. In this question, it's not specified what severity of illness is categorized into, so we won't define it here. So there are two instances when the intervention or treatment is set to 0. In the first instance, adverse outcomes are mainly due to random chance. Now when we look at the equation for adverse outcomes, we see that adverse outcomes equals alpha plus beta sub 1 plus beta sub 4 plus e. When beta sub 4 has been given a 0, it cancels out, leaving with alpha plus beta sub 1 plus e. Now in this instance, severity, or beta sub 1, has also been given a 0, so it will also cancel out, leaving with adverse outcomes amounting to alpha plus random chance. In the other instance, adverse outcomes are due to both severity and random chance. Looking back at our equation for adverse outcomes, when we set the treatment to 0, again we are left with alpha plus beta sub 1 plus e. Because we do not know how severity was categorized in this question, we will just leave the value of severity as x. This leaves us with a final equation of y equals alpha plus beta sub 1x plus e. This concludes my Teach 1 presentation. I hope it was helpful for you guys. If you have any questions, please comment below or message me directly. Thank you.